Look at how we currently try to solve planetary crises. We gather world leaders in a room, negotiate for weeks, and draft massive single-issue treaties like the Paris Agreement to cap carbon emissions. The flaw in this approach is built right into its design. These treaties rely almost entirely on voluntary participation. If a nation decides to ignore its carbon targets, enforcement comes down to political pressure, which shifts depending on who happens to hold office. We are attempting to manage complex global systems without an objective ruler. We lack a mathematical baseline to measure the actual ethical and operational health of a nation. Compare that to the physical sciences. A thermodynamic equation doesn't negotiate. It defines exactly how a system balances energy and resists decay. As long as international governance relies on shifting human opinions rather than absolute structural rules, global stability will stay fragile. We simply cannot optimize what we cannot accurately measure. This measurement problem is exactly what researcher Petar Nikolov addresses with U-theory. It operates on a premise that bridges theoretical physics directly into macrosociology. The model treats a nation-state as a literal physical system, subject to the same requirements for stability as any other complex structure. This framework provides a computable, universal language for structuring governments and, crucially, aligning artificial intelligence. The entire model rests on a single mathematical triad. The stability of any system, U, equals the cube root of its form multiplied by its position multiplied by its action. When applied to human societies, the first physical variable, form, translates to code. This represents a society's core ethics and its strict refusal to cause harm, tracking metrics like corruption and pollution. The second variable, position, becomes rights. This maps the structural dignity of citizens and the correctness of the expectations they place on the system. The final variable, action, translates to credo. This measures pure organizational efficiency, continuous learning, and tangible public benefit. When all three elements are equally weighted, the system actively minimizes what the model calls social entropy. Political stability, in this view, is a literal physics problem, requiring an exact balance of ethics, rights, and efficiency. We can test this in the real world. In 2025, researchers applied this formula to modern nation-states to calculate objective stability, producing a massive dataset. Germany emerged with a high U-score. The data reflects a heavily balanced triad across code, rights, and credo, which translates to distinctly low political entropy and high system efficiency. Contrast that with China. The model reveals a strong but imbalanced structure, driven by extreme action and efficiency, but maintained by heavily controlling the position, or rights, of its citizens. Turkey registers as a system generating severe internal friction. When the triad becomes this misaligned, the societal energy that should go toward productivity is instead lost to systemic heat and instability. South Africa scored very low, suffering from what the theory calls a form collapse. Despite massive economic potential, a breakdown in foundational ethics and anti-corruption codes leads to extreme social entropy. These scores suggest the rise and fall of superpowers track with the laws of thermodynamics far more reliably than they do with traditional political science. This brings us to the immediate advantage of the U model over current legal systems: mathematical computability. While human-written treaties are too ambiguous for a machine to parse, an AI can be programmed with a clear objective function to maximize a unified U-score. International bodies like the European Union and the UN are already showing partial structural alignment with these kinds of integrated multivariable tracking models. Because the U-score formula makes rights and ethics essential to the total calculation, an AI cannot maximize its objective by sacrificing human dignity for system efficiency. This creates a mathematical containment field, providing a tangible path to resolve the AI safety crisis. The structure of international policy is pointing away from single-issue treaties, like carbon quotas. Instead, the focus moves towards comprehensive audits, tracking a nation's corruption, its system efficiency, and ecological impact simultaneously. The rigid academic walls that have long separated the disciplines of sociology, economics, and quantum physics are actively dissolving. Politics is giving way to a unified scientific discipline based on physical laws: triad engineering.